Here we go. Start recording. So without further ado, Simon will give us an overview of the Pacific Cup weather and how to navigate to Hawaii. He'll tell us some of his navigational secrets. He'll tell us the story of his winning 2014 race where he won his class on the Hobie 33 Por Favor as navigator. And he'll just share some other insights into weather models, hurricanes, and other interesting weather factoids that he's familiar with as a professional meteorologist. So let's go, Simon.
All right, thanks, Corey. So here we are. I guess the whole goal of spending some time looking at this weather business is to try and basically get to the Mai Tais as fast as you possibly can. And one thing about sailboat racing, as we all have probably experienced over the years, that you often hear they got lucky. And over the years and decades, it often seems like the same people seem to keep getting lucky over and over and over again. And I think really putting the effort and time into really looking at the weather in detail before the race and kind of getting a good feel for what your overall strategy is going to be and so on is one of those things that will give you a better chance at being one of those lucky people. So we'll just kind of look a little for a second at the kind of guiding principles of all this. So you're really trying to have the best possible picture of the weather's evolution from the time you start until you expect to get to the finish line. So monitoring the evolution of the weather through forecast models and model analysis and so on over the days and possibly as far out as 10 days before the start really helps you to build that picture ahead of time. And secondly, you really want to know the race course and the kind of stages of it. And I can't thank Stan Honey enough for his excellent short little articles about the Pacific Cup and strategic thinking, and particularly his descriptions of the stages of the race and where they start and finish. So as you build your kind of picture of the developing weather situation, you should be able to identify pretty clearly where each stage is going to begin and end. And so particularly getting a feel for where the transitions from one stage to the next are going to occur, and particularly that stage of crossing the corner of the Pacific High on your way. That's assuming, of course, that the Pacific High is actually present and that it might kind of look something like what it should normally look like at that time of year. Your best confidence in the models, because of course the models can have an excellent analysis, meaning their picture of the existing conditions when the model run starts is always very good. And the forecast, if all goes well, should be quite accurate for at least the first 3 days. And that's particularly important because in the Pacific Cup race, the first 3 days are really crucial. Your major strategic decisions for the race really hinge on that first kind of quarter to 1/3 of the race and how you position yourself relative to your competitors. So the first 3 days are really crucial, and that's where you're going to have the best confidence in the models. So that's kind of a factor going in your favor. And then you want to be assessing your confidence in the models basically as an input into a benefit cost ratio of how much distance it's worth sailing. So if you're going to do extra distance, make sure that you're really confident in that forecast that you're basing that decision on, and have a good think about the benefit cost ratio. Is it really going to be worth doing those extra miles? And of course, as the race goes on, the daily position reports and tracker information can really help you sort of fine tune that stuff. You know, is your strategy working out versus your competitors and so on. So that's kind of the starting point. The big picture here, if you look at the course from San Francisco Bay to Oahu, as time goes on, you should be able to get a feel for whereabouts along this track there are various phases of the race start and end. And so just for example, I drew 2 arbitrary points in here on 130 degrees west longitude, because I think that is generally somewhere close to where you're going to cross that ridge that's extending southeastward from the Pacific High. Over time, as you get closer and closer to the start, you might want to adjust that position, either further west, further east, depending on how the high shapes up. But one of your first big decisions certainly is going to be, where do you want to cross that line of longitude? Should you be south of the run line, and if so, how far? Or should you be north of it, and how far? That kind of thing. So that's one of the first big things. So really, you're trying to build that idea of where the different stages of the race are going to start and end. So that's kind of the big picture. What kind of data sources do we have to start our analysis with? We've got a whole variety of different models and buoy reports, ship reports, etc. Starting with the global models, first on my list here, ECMWF. This is really, really exciting, and I think potentially a game changer for weather routing and navigators in general. The European Center for Medium Range Forecasting, ECMWF, has been the world's leading, most accurate global model for several decades now. But it's only very, very recently that its data has become available for free in GRIB formats. And I think this is probably the first race to Hawaii in which that's the case. So in the past, we've only been able to really use the GFS or possibly ICON, the German model, or the Canadian GEMS model. But now with the ECMWF in there, it's really a game changer, and that's very exciting. Then there's closer to the coast, there's the NavGem. That is what used to be known as the Naval Research Labs NOGAPS model. It's been renamed NavGem. It got a bunch of upgrades into its physics schemes and so on, so it should be pretty good. COAMPS has been around for a long time. HRRR is high resolution rapid refresh mesoscale model. So it basically is primarily for the continental US, but it does spill over into the coastal waters somewhat. So for nearshore stuff, those are 3 that are also worth looking at. Next, we got a human being plus a model. So the human can take the model output and then draw various features on top of it and add some value with things like the projected position of certain features in his analysis, where the low is going to move to, for example, that kind of stuff. And I'll show you an example of that later. And you can look online for a thing called the Northeast Pacific Briefing Package. There's a lot of excellent information in there. It's got 500 millibar stuff, surface analysis and forecasts, as well as wave heights, et cetera, et cetera. It's all there. So that Northeast Pacific Briefing Package is a really valuable resource. Then the National Buoy Center, Data Buoy Center. So that gives us data in near real time from a variety of weather buoys offshore. There's one about halfway out to the Farallones, just outside San Francisco, that's particularly valuable. And there's another one just slightly northeast of Oahu which I can't remember its number right off the top of my head, but those are pretty valuable. And also ship reports. Ship reports are available in various places. My favorite place to look for them is on the Windy website, which I'm sure most of you probably are familiar with. But if you see a little brown dot on the Windy map thing, it's usually a ship report, and that'll give you the most recent wind speed and direction information from that ship report. So those are really valuable. Scatterometer winds. At one time, these were considered to be a really super valuable resource. They're derived from satellite, and the satellite measures reflectivity off the ocean surface, and it looks at the reflectivity is influenced by waves. So it looks at the the reflectivity off the surface, filters out the ocean swell component, and just looks at wind waves, and is very accurate at figuring out what the wind speed and direction is from the wind waves. 10 years ago or so, it was considered to be a superb resource, but since then, the scatterometer data is now being ingested into the forecast models automatically. So the forecast analysis will already include data from the scatterometer satellite-based stuff. So it's probably no longer really worth spending a lot of time looking at that stuff. So anyways, there's our data sources: global models, mesoscale. And mesoscale is a model that's just looking at a smaller component of the Earth's ocean atmosphere system. So it's, instead of trying to model the weather over the whole globe, it applies all of its computing resources to a smaller domain. They forecast for a shorter time out into the future, but they're generally quite a bit higher resolution, and they include the effects of coastal things like headlands, mountains, et cetera, et cetera. So very good for nearshore forecast information.
Hey, Simon.
Okay, so there's our.
I have one question here.
Okay.
Why is the ECMWF more appealing than the GFS forecast?
Well, the ECMWF model has it's traditionally, the models kind of all in the meteorology field, we kind of jokingly call it the model Olympics. And so every year, all the various agencies that run global forecast models they do verification statistics. So they look at how their model verified in reality over various timeframes, 24 hours, 48 hours, 72, and so on. They compile some statistics on the verification. And for quite a few, I think for almost 30 years now, the ECMWF has come out on top almost every time. So it's just considered to be that extra little bit more accurate. It's not to say, GFS is a great model, but I think if you spend some time reading forecast discussions where they talk about which model they're favoring and so on, it's surprising how often the forecast, particularly as you move out past the first few days, the forecasters will always say we're starting to lean towards the ECMWF solution. So it's just gives you a little bit extra accuracy, and I think it's probably the highest value model. Any other questions, or should we go ahead?
That's all I've got so far, and Carl says
Okay.
the explanation.
So I think we want to look at kind of the stages of preparation, and there's a million different approaches to this whole thing, so I'm just going to tell you about mine. And I owe a lot to our dear colleague, Lee Chesnow. And he was very big on certain aspects of this method of preparation that I'm going to talk about. So basically, in the long range, I'm talking about, maybe a week or 10 days out before the start. basically, you just want to follow the evolution of the weather. You want to see how things are changing as you get in time closer and closer to the start date. And I'm saying that's kind of leading up to kind of the last 3 days before the start. So this is kind of long range stuff. In the last 3 days, you want to start focusing in on really what's your strategy going to be. Before that, you just want to, oops, sorry. Before that, you just kind of want to follow the evolution of the patterns, see if you can get a feel for how well the models are working, and evaluate their consistency from run to run. So, don't bother with every 12 hours, just kind of once a day, or even, if you don't have time for all this stuff, maybe every second day. Compare that day's analysis with the forecast from 2 days ago, see how it looks. If you can, grab those grids and stick them into your nav software and try and get an optimized route, or eyeball off the weather map and just kind of guess what your optimized route should probably look like, and then make a little sketch of it. Something like what I've got in the picture here. So the straight line there is basically the run line of the race course, and the curving thing is the optimized route. So in this case, that optimized route might be by eyeball, or it might come out of your navigation software. And it doesn't matter whether you're using Expedition, Adrena, Squid, whatever. There's a whole variety now of nav software, and I would assume that most people are probably going to use one of those kind of programs to do this. Predict Wind, I think, also has a routing option. But once you've kind of had a look at the thing, then just make a little sketch of what your optimized route looks like. Note, sorry, screen keeps jumping around, and make a little note of what was the distance and what was the time to finish, assuming that you were starting that day when you downloaded that grid. And then over time, then you should eventually, you keep doing that over and over and over again, multiple models, multiple runs of the same models. And as far as start time, in the long range, it's not important. Just pick a realistic time of day. So sometime in the morning, when you feed the grid into your nav program, pick a start time that's somewhat close to the model's initialization time at the right time of day. So sometime mid-morning or whenever your start is likely to be. So over time, you should end up with something that looks like this page out of my little notebook from, I think this was leading up to a Vic Maui race a few years ago, but you end up with a whole bunch of these little sketches like I just showed you. And you should be able to see over time how they evolve, and are they starting to look like they're all the same shape? Does one model have a different shape than the others, et cetera, et cetera? So for example, on the top row of my little sketches here, the Canadian model had us crossing the run line from south to north quite far out. Or sorry, that was the GFS model. Canadian model had us crossing the run line a little closer, but going further. Pacific Wind GFS model, kind of similar shape, and Pacific Wind on the Canadian model, kind of similar. So there were 4 models that all looked not too far off in that particular case. So over time, you want to build these up. Now, you don't necessarily have to sketch them in a notebook like this. I mean, you could be just saving a screenshot out of your nav software, for example, but make sure that you compile them in some kind of logical sequence so you can kind of follow the evolution. So over a few days, now we're leading up to the kind of getting into that 3-day window before start time. So we should have a picture of where the models want to send us. So now we're going to get into the shorter range stuff here. So in the last 3 days, you want to change your focus slightly and start to look at model calibration, which really means just an assessment of how well the model is representing reality. Sorry, jumping around again. And now, because you're into the last 3 days and you know that the forecast for the next 3 days leading up to your start time should be pretty good. So now start to do your optimization based on grids that start at 12Z on the start of your start day. So you can plug the start time of the actual race start into your optimization thing. And then now you can see in that last 3 days how consistent things are, because you're really comparing apples to apples. You're starting at the same time for every model run. And ultimately, your goal is to try and estimate your confidence in the forecast. And you're going to use that as input into your cost benefit ratio. So for example, if your route optimization is telling you to go way far away from the run line at some stage, particularly in the early stages of the race, really start questioning, are those extra miles going to be worth it? And so that your confidence in the forecast really is a really high value thing here. And if conditions look somewhat normal, meaning that the Pacific high is somewhat established and you've got kind of the stages of the race laid out as per what Stan Honey describes in his excellent articles, then you should be able to figure out where the transition is going to happen from what Stan calls the windy reach into crossing the ridge, and estimate the longitude of where that corner of the ridge is and set a target of where to cross it. So just as an example, like I showed back on my original picture, Google Earth picture there, where should we cross 130 west? Well, now you might have a better idea of, is it 130 west, or is it 127, or is it further out? Is it maybe 133, whatever. But you should be now building up a picture of where the corner of the ridge is and see where your route optimizations are telling you to cross that line of longitude. And then really keep close track over the next couple of days leading up to start time of how consistent are those predictions. That's all kind of confidence in the model thing. So here we go. So calibration, really, I mean, you're not actually tweaking anything about the model. You're just trying to calibrate how accurately is it representing reality. So you can compare the model's analysis with buoy reports and surface analysis with human input, and you can investigate the run-to-run consistency and compare. And to do that, compare the model's analysis today to what its forecast was from 24 hours ago. And you might even want to go further back, maybe 48 hours ago, 72 hours ago, 96, whatever. All depends on how much time you have to kind of reiterate this process. And remember that the initialization, where the model is ingesting all of the available data from every possible source to come up with its snapshot of what the atmosphere looks like at the model's start time or initialization time. So that's the most accurate thing about any output from any weather model, is its analysis. And then it starts to forecast into the future. So you want to have some idea of how good the analysis is. There's a lot of, it's not a simple process. There's an awful lot of computing horsepower goes into this model analysis stuff. And if you're starting to have any doubts about maybe the analysis is starting to not look like reality based on things like buoy reports, the surface analysis from a human being, or ship reports or things like that, then you got to start putting some big question marks in there. So calibrating the models. So here I've got a picture of a grid in a grid viewing program, and this was the 24-hour forecast from yesterday, and it's valid at 12 Zulu or 5 a.m. Sorry, 4 a.m. This morning. So that's the model's picture from yesterday of what this morning should look like. On the right over here is the Pacific surface analysis, and this was critiqued by forecaster Collins at the Ocean Prediction Center. And one thing you have to kind of come to grips with here is figuring out, you're obviously looking at two different frames of reference. So you've got to be able to kind of translate lats and lawns and the shape of these grid boxes in the model domain versus the shape of the grid boxes in the surface analysis. You can see they're slightly different, but effectively we've got pretty similar things here. We've got a high of 1,029 millibars, and it is in exactly the same position as the 1029 millibar high on today's analysis. We've got further west, we have a low at 1,017, and it's kind of a trough here, and 1,017 millibars, and the 24-hour forecast from yesterday in the model, also 1,017 millibars, and it's in virtually the same kind of location. Possibly it might be nudged a little bit northeast of where the model forecast had it, but looks pretty good. The pressure's the same. And further west, north of Hawaii here, we've got this 1,021 high, and the model yesterday had 1,022, roughly, with a slightly elongated high there. So in general, and I should also mention the cold front trailing off that low there is the triangles shapes on this line. That is very clear in the model grid forecast as the transition there from really strong winds along the cold front, ahead of and along the cold front. And it follows the same path in today's analysis. So basically, so far, looking pretty good. So I can say now pretty confidently that, well, yesterday's forecast model did a pretty darn good job of predicting today's weather. So yay, that's a plus. It's a good thing. And so here's today's 12Z analysis. So in the previous slide here, we were looking at 12Z today, but as a forecast from yesterday. And now we're looking at 12Z today as the analysis by the same model, same ECMWF. And the only real change here, we still got the low. It's still 1,017. It's now being analyzed slightly further south a little bit. It's still got the trailing cold front. The high to the west is still around 1,022 roughly. And now the 1029 high has kind of become elongated in a northeast to southwest direction. Those are really the only significant changes. And I'd say in the big scheme of things, probably not super important. So far, we're still looking pretty good. Finally, let's look at some actual observations here. So we've got buoy 46026, which is roughly halfway out to the Farallones from San Francisco. And it's reporting at 2020, which is sometime early this afternoon, I guess, 17.5 knots. And I looked in the forecast grid for the same time, northwest, 18 knots. So far, that's all looking good. And you might be able to dig up some ship reports. Again, I said the Windy website generally has ship reports posted on it if any are available. So those are another good source. You can find the lat long of the ship report, find that lat long in your grid file and compare the the data. So, so far, things are looking pretty good. What if they're not, though? And so that process that we just looked at there, I'll just back up for a second here. I'll go back 2 slides. This whole process of calibrating the models, you want to kind of keep doing that. And I just used a 24-hour example here. It's probably worth, certainly in the last couple of days before your start, repeat this for longer time intervals. Maybe go 24 hours, 48 hours, 72 hours, etc. But keep it up and use at each step of the model run, each day of evolution into the future, kind of keep an eye on how things are looking compared to the previous forecast model. And that'll really give you an idea of consistency. What if the models are not agreeing? Because what we just looked at there, things to me, if we were starting our race, in the next day or two, I'd say it looks like the models have a good handle on things and it looks great. What if that's not the case? Maybe all those little sketches that you made of your optimized route, what if from day to day they're bouncing around all over the map? One day it wants to send you way north, the next day it wants to send you way south, and you're just scratching your head. Well, one thing you can count on, particularly in the early stages of the race where your biggest decisions are made, the benefit cost ratio of getting too far away from the run line is probably very low. So really be cautious because you don't have much confidence. So potentially the benefit cost ratio of sailing extra miles could be even very negative. So be careful. Then even if the big picture was looking different every day from model run to model run or between models, one model saying one thing, another model saying another thing, and then the next day they flip-flop back and forth. With any luck, maybe there was at least one feature that was consistent. And if so, put that into your analysis of kind of cost-benefit ratio stuff. And be prepared to adjust your strategy, of course, as you go, because things will unfold. The actual conditions, even though you didn't know them before the start from all this analysis work you did, they will start to become apparent once you're underway. And so be prepared to adjust your strategy. And I think that the 2014 race was a very good example of having low confidence in the models. My little sketches that I was drawing in the week leading up to the race were completely all over the map, talking on the docks and so on, and the various pre-race social functions and so on. All the navigators were just scratching their heads and going, boy, this looks like a wild crapshoot here. So what are we going to do? And particularly, one of the old kind of standby bits of conventional wisdom in this race is that if things are weird, go south at the start, recommending a southerly course in the early stages. And in that particular year, the routing software was kind of leaning that way, recommending a big dip down south off the start. And also some people who were subscribing to professional weather routers were getting the same kind of advice. But the one thing that was consistent that particular year was that there was a stripe of really strong northerly winds just off the California coast by Cape Mendocino, which of course, as most of you know, that's not at all unusual, but it was way north of the race course. And as that wind moved south, it was fanning out and slowing down. But at least it was there every single day in all of the days leading up to the start. And so we really started to look at, sorry, I'm jumping around again. how wise would it be to dip south at the beginning, with the knowledge that the only consistent wind that had been forecast was actually to the north of the run line. And as it turned out, sure enough, we spent the first night on the boat slatting off the Farallones in virtually zero wind. I think we had the drifter up and down probably half a dozen times that night, and it was kind of horrific. We were at times going maybe 1 knot if we were lucky. At daybreak the next day, we could see that our fleet was kind of spread out considerably from north to south. And as the day went on, we noticed that very, very slowly, the boats to the north of us were starting to move. And we kind of threw caution to the winds and decided, that's what the models had been telling us, that the only wind anywhere was to the north of us. So let's go that way. And that was pretty much the deal. By the morning of the second day, we had a substantial lead over the rest of our division, and we managed to hang on to it for the rest of the race. But really, in that case, the models were not agreeing at all, and our decisions really were made just by looking around us on the race course and we had to adjust. But the Farallones, of course, are virtually right on the Great Circle route from the Golden Gate to Oahu. And so it just made sense to, in the early stages where there was hardly any wind, as the first day was coming to a close, stick to the run line and just kind of drift our way out to the Farallones and then see what happens from there.
Simon, can I ask a couple of questions?
Yes.
First of all, why is a slightly southerly route often suggested in times of uncertainty?
That's a very good question. I think that it's generally, all I can tell you is that it is considered to be kind of conventional Pacific Cup wisdom. I think if you looked back over a few decades of the routes taken by the winning boats in various divisions, generally the most common route starts off going south of the run line, and I think that's probably where that thing was based. And I guess it's just saying, well, that route's always worked in the past, so if you don't know what's going on weather-wise, follow the route that winners have taken before.
That makes sense.
May not be much of an answer, but
yeah.
I think that's where that comes from, probably.
The other thing I was wondering about, when you talk about assessing model confidence, you didn't discuss much comparing what different medium-term forecasts might have to say, for example. You're talking a lot about the day-to-day variance of an individual forecast.
Yeah, I'll back up here a bit, go back a few slides, boom, oops, passed it. When I was talking about, kind of getting ready in the longer range here, I'm looking at each day, in this particular case, 4 different models and comparing them. And then the next day, compare the same 4 models. So, and so you can repeat that process of comparing yesterday's forecast with today's analysis and then today's reality based on buoy reports, the Pacific surface analysis and ship reports. And if you've got the luxury of time to be able to do that for as many possible models as you can, then great. More bigger database of where your confidence feeling is going to come from.
So how would you kind of weight the kind of like the evolution of a single forecast and the uncertainty in that versus the uncertainty between different forecasts? Like if the Euro model disagrees with the GFS model, is that usually a worse sign than the Euro model being wrong today, or would you say that, you know, being wrong on the 24-hour forecast is a much bigger calibration issue?
I think those two probably have equal weight.
Okay.
Model to model versus run to run of the same model should kind of be valued equally as inputs into your assessment of confidence.
Great, thanks, Simon.
So there's always a few possible wildcards. Cutoff lows are one, and a cutoff low means, and here's an example of one from that surface analysis that we looked at earlier. The cutoff low has completely closed circular isobars surrounding it. And that means that it's isolated away from the surrounding features of it. If we look at this low in the center of the picture here, the 1017 low, it doesn't have closed isobars around it, right? It's basically just a trough of low pressure. So two different things. The trough, this one that's here evident, if you see something like that that's coming up within the next day of your adventure, you probably would want to think about routing around the southern edge of it. However, a cutoff low is a different story. The cutoff low is going to have more adverse weather to the south of it, and potentially quite horrifically adverse, especially if it's got a nasty cold front trailing behind it. Whereas passing to the north of the cutoff low is probably going to be big time advantage to you. The old gentlemen don't sail to windward adage comes to mind there, nor do gentle women either. So cutoff lows you kind of got to watch out for, and you'll be able to identify them in the grid file. You can also see on this analysis map here, it's got an arrow from the X is its position at 12 Zulu today, and there's an arrow pointing to an X which represents, that would be its position in 24 hours time. So 12 Zulu tomorrow, that particular cutoff low is progged to be well to the north of the of our area of interest, and it looks like it's probably on its way towards Canada. We'll probably get some eventually, a few days time, probably get some nasty weather out of that. The low trough that's in the middle of the course here, that's closer to our actual racetrack, it's progged to move by tomorrow into the position where the high was today. And if we went back and looked at that grid forecast for tomorrow, we would see that indeed the high has moved quite far eastward to the coast, and now this low will be tomorrow where the high was today. So look for those the arrows on those features and the X's marking the 24-hour position of them. And keep in mind that a trough like this over time could evolve into a cutoff low. So far it's not, but it could become one. So these cutoff lows are worth looking at. And in general, if there's one time when it might be worth sailing some extra miles, it might be to stay on the north side of a cutoff low. Going to the south of them is potentially quite dangerous.
Simon,
so,
Bob asks if there's any sort of rule of thumb to determine if a trough might evolve into a cutoff low in the short term.
Well, you should, if it's a well-known feature, if it's showing up on the surface analysis by a human forecaster, and it's also showing up at the same location in your model forecast in grid format, then you should be able to hopefully use the grid to determine If the grid says it's going to turn into a cutoff, then there's probably a good chance that it will. Does that answer the question there?
Bob gives you a thumbs up.
The other thing, you can also, in that Northeast Pacific briefing package, we're just looking at the analysis here. This was this morning's analysis. In that same briefing package, you would find a surface analysis for tomorrow and for 96. I think also for 72 and then for 96 hours in the future. So if that was a real concern, you could look and see how the combination of human forecaster plus model also evaluates that and see how it looks over time. And if you start to see the closed circular isobars around it, it's becoming a cutoff low and could be a bigger problem for you. Okay. So what about hurricanes or tropical depressions? These have historically come into play in the in various races to Hawaii. And unfortunately, it's too soon right now. The Pacific bulletins from the National Hurricane Center don't start until June 1st. So you'll have lots of time between June 1st and leading up to race time to kind of keep track of that and see how things are evolving. But as far as things are right now, here's sea surface temperatures, which of course are the biggest influence on the likelihood of tropical depressions or hurricanes forming. And we still have La Nina, right? We've got cool ocean surface temperatures all along the equator through the entire Eastern Pacific, from the date line all the way to the coast of South America there. So that's kind of La Nina, but La Nina is weakening. And by midsummer, supposedly, according to the latest forecasts, La Nina will be gone and will be kind of into a neutral situation. So neither El Nino nor La Nina. But as things stand right now, we do have kind of an area of very warm, we've got a +1, between 1 and 2 degrees C warm anomaly over the kind of the Hawaiian island chains and to the north, and some slightly warm waters kind of off the coast of Mexico and off across that kind of latitude band towards Hawaii. And so we want to carefully watch the evolution of that over the coming months. Particularly, can really start looking at it around June 1st and see how the Pacific hurricane season might be shaping up. And if it gets down to the last, few days before the race and you're starting to see potential for a hurricane moving across the race course at some point, you have to very quickly assess as best you can what it's forecast to do, how rapidly it will weaken as it moves away from the equator, and try and get a feel for, okay, is this going to be a survival situation or something that is just going to be kind of avoidable and we can maybe take advantage of its outer fringes or something like that. And that's all I have for you. So are there any last questions? So okay, the National Hurricane Center, very easy to find online, of course. And like I say, June 1st, bulletins will start up.
You have 2 questions here for you, Simon. The
Okay.
first one is, assuming limited download capabilities, how far ahead in distance would you pull GRIB files?
That's a good question. The file sizes are not really that big, even if you're looking at the entire course. You can, of course, reduce those file sizes by looking at a smaller domain, smaller box of latitude and longitude, and also the time resolution. Instead of asking for a grid that shows you a forecast for every 3 hours, you might go every 12, and then 24, and then 72, and then maybe go 4 days, 6 days, whatever. So you can adjust the time steps that you request your groups for, and you can also limit the domain. But I'd say generally, in the early stages of the race, you probably want grips for at least the first half of the race course once you're out there and concerned about your battery power and bandwidth, et cetera, et cetera, et cetera. How much time do you want to spend with your modem fired up pulling in grid files? But you can consider limiting the frequency of the grid forecast intervals. And certainly once you're out there, probably getting it for every 3 hours is probably not worthwhile. Maybe cut that down to 12, 24, and then go 48, 72, et cetera.
Carl asks, how often do you run routes underway, and how does that cadence change?
I guess that's quite variable. I would say ideally you'd probably want to do it once a day. But if you're into again, it all comes down into your confidence in the forecast. If it looks like things are settling into a fairly consistent pattern, sure, you could skip a day or even 2 days. But if it looks like things are rapidly evolving, then be careful. You don't want to miss some transition in the weather pattern. So you might even, if things look like they're changing rapidly, you might even do it twice a day, for example. And generally, I would try to use the 12Z and the 0Z model runs, if that were the case. But once you're kind of underway and you've kind of got the first quarter to 1/3 of the race under your belt, with any luck, you should be able to kind of slow down on your analysis and strategizing activities and concentrate on the sailing. But that certainly is not the case every time. So if there's features that are, if there's a potential for a cutoff load that's on the move, then certainly keep at it. Do your routing routine more frequently and keep an eye on that situation.
Great, thanks, Simon. Bob asks, is there anything special to consider in the last couple of days before the finish? Anything particular to look at?
Well, hopefully you'll be solidly sailing in the trade winds by then. And I mean, the model stuff won't really help you with determining whether there's going to be squalls at night, for example. The only thing is, generally, if there is going to be a tropical depression or a post-tropical depression interfering with the racetrack, it'll probably be somewhere within the last few days. So you'd want to keep an eye on that for sure. But generally, assuming that you're kind of solidly sailing in the trades, then the traditional advice probably rules. Somebody like Stan Honey, who's done this race many, many, many times, has written excellent information about it, has really good advice on the latter stages.
One more question. How does the neutral sea surface temperature, or I guess the kind of neither La Nina or El Nino year, affect the trade winds in general?
I would say it should generally lead to a fairly kind of normal situation with, by race time, you should have ideally a fairly well-established Pacific high, and the trade winds should be pumping along in their usual fashion. the usually the kind of weirdness starts showing up if you have either a strong La Nina or a strong El Nino. So the move towards neutral, I think, kind of leads me to think that conditions should be tending towards, climatology.
Great. Well, I think that's the last question we have. So we can all look forward to hopefully a classic Pacific Cup this year. Simon promised us. Yeah, so thank you. I just want to remind everybody that Simon volunteered his time to come share all of his expertise and knowledge with us tonight. So big thanks to Simon. And I hope you guys all got a lot out of this. We will definitely post the recording of the video online. I'll see about the slides, but I think in general, you'll probably get more value out of having Simon's commentary along with just the text on the slides. So you've been offered a Mai Tai and Kaneohe if you are there, Simon. And everybody is very grateful. And thanks again, and we'll see everybody around the race course, the Pack Cup, and sailing. Thanks, guys, and have a great
All right. Well, I just want to say it's been a huge pleasure to speak to everybody, and wish everybody a fantastic, fun, and safe race. So all the best.
Cheers.